So this box here shows to us how diffusion-weighted images are made. Remember this zigzaggy line that we saw earlier? Okay, this is the RF pulse, which gives extra spinning energy to the protons. Because we see here that the RF pulses here are paired, meaning we have 90 and then we have a 180 pulse sequence. This diagram shows us a spin echo sequence. Again, spin echo sequences are characterized by a 90 and a 180-degree pulse. Okay, to make a DWI image, we're going to first create an image similar to the mother sequence of DWI, which is something that looks like this. Okay, this image here was created by shooting a pair of RF pulses here, the 90 and then the 180. Look here on the left, we label here. There's a label here that's called B0. So what is B0? What is a B value? The DWI is actually a spin echo sequence, a 90 and 180, okay, but with a twist. Okay, you can think of this modification or twist as firing two additional gradients. Okay, this blue and this red. The blue one is given after the 90. The red one is given after the 180. Another way to think about it is that these are the gradients are in the form of dodgeballs. Okay? These blue balls are going to hit the proton once, and if this proton doesn't move a lot, if it's stationary, if it's confined, or it's restricted, it's going to get hit again by the red dodgeball. Okay? The formal term for this blue gradient here is the dephasing gradient. Dephasing gradient of the synthesizing gradient. Okay? Anyway, protons which get hit twice are going to get bright on DWI, while those which are mobile or free water, for example, are just gonna get hit once by this blue dephasing gradient. Okay, and will therefore be darker on higher B values. Okay, going back here to our image here. So notice here that the B value is 0, meaning no gradient was given, no blue, no red dodgeball. So this is just a basic T2 sequence. Notice here that this B0 value looks very much similar to this T2 weighted sequence. Okay, the next step for creating the DWI is to now create another 90 and 180 pulse sequences or spin echo sequence, but this time we're going to use this, or we're going to create or shoot a blue dodgeball and a red dodgeball. Notice here that this one, free water within the ventricles, okay, already became dark on this higher B value. Okay, this is because the water, okay, gets only hit by the first dephasing gradient. It does not get hit by this rephasing gradient or this red dodgeball. Okay, now these two images, the B0 and the B1000 images, are now combined to give us this DWI image. And this is the form or the the actual images that is sent into our fax machine. Now, what about the partner of DWI, which is ADC? Okay, this two images, the B0 value and the B1000 values, are processed by the computer. Okay, so let's take a look at this graph first. Okay, we have here a graph showing to us what is the signal, okay, here of the normal tissue as you give increasing B values. Notice here, if you have normal liver tissue, the signal here obtained from a B0 value is going to what? Decrease as you give higher B values. Okay? If we compare the signal of the normal tissue with that of a tumor, which we're going to assume has restricted diffusion, okay, the signal here is also going down, okay, as you increase the B value. If you compare the two, the tumor here and the normal tissue here, which one would give you a greater loss of signal? In other words, which of the two lines will give us a steeper slope? Is it the normal liver, this sloping line, or the liver tumor, this sloping line? Notice that it's the normal liver or normal tissue which is going to give you a steep line here, steep slope. Okay? When the MRI machine is going to see or detect that that tissue has a steep slope of signal loss on increasing B value, it's going to code it or show to us on the ADC maps as something bright. While if it detects that the slope here is relatively not steep, non-steep a slope here, it's going to code it into our ADC maps as something which is dark. Okay? There. So initially, it may be helpful just to memorize the pattern DWI bright when paired with an ADC dark signal is something which is bad because it's seen in infarcts, it's seen in tumor. But understanding this general principle on what normal and abnormal would look like on increasing B values is helpful because we're also going to see DWI and ADC sequences in MRI examination for other parts of the bodies and for different types of lesion.